Hello everyone, and welcome to this video where I'll be reading through the OpenStax.org textbook called Prealgebra, and it's the second edition. And I'm specifically going to be reading through and doing examples from section 1.1 called Introduction to Whole Numbers. And I'm going through the part of that section with the heading Identify Counting Numbers and Whole Numbers. So here we are at the site openstax.org. Again, it's Pre-Algebra 2nd edition, section 1.1, Introduction to Whole Numbers. So at the beginning of every section, there are the learning objectives for that section. So by the end of this section, you will be able to, do the following. Identify counting numbers and whole numbers. Model whole numbers. Identify the place value of a digit. Use place value to name whole numbers. Use place value to write whole numbers. And round whole numbers. So in this video, I'm specifically going through the heading Identify counting numbers and whole numbers. So learning algebra is similar to learning a language. You start with a basic vocabulary and then add to it as you go along. You need to practice often until the vocabulary becomes easy to you. The more you use the vocabulary, the more familiar it becomes. Algebra uses numbers and symbols to represent words and ideas. Let's look at the numbers first. The most basic numbers used in algebra are those we use to count objects. 1, 2, 3, 4, 5, and so on. These are called the counting numbers. The notation with the ... is called an ellipsis, which is another way to show and so on, or that the pattern continues endlessly. Counting numbers are also called natural numbers. So the counting numbers definition. The counting numbers start with 1 and continue 1, 2, 3, 4, 5, and so on, right? So 6, 7, 8, 9, 10. To get from one to the next, you just keep adding 1 or putting on 1 more. Counting numbers and whole numbers can be visualized on a number line, as shown in figure 1.2. So here is figure 1.2. The numbers on the number line increase from left to right and decrease from right to left. So you can see a line here with notches representing the numbers 0, 1, 2, 3, 4, 5, 6, and they show you the arrow up top. The arrow up top goes from left to right, and as you go from left to right on the number line, numbers are getting larger. So 1 is larger than 0, 2 is larger than 1, 3 is larger than 2, 4 is larger than 3, 5 is larger than 4, 6 is larger than 5, and so on. And then the second arrow is going from right to left, saying smaller. So as you go from right to left on the number line, numbers are going to be smaller, getting smaller. So starting with 6, 5 is smaller than 6. 4 is smaller than 5. 3 is smaller than 4. 2 is smaller than 3. 1 is smaller than 2. And 0 is smaller than 1. And so on. We'll get to the left side of 0 here eventually. The point labeled 0 is called the origin. The points are equally spaced to the right of 0 and labeled with the counting numbers. When a number is paired with a point, it is called the coordinate of the point. The discovery of the number 0 was a big step in the history of mathematics. Including 0 with the counting numbers gives a new set of numbers called the whole numbers. So here's the definition of whole numbers. The whole numbers are the counting numbers and 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dot, 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 right? And so on. We stopped at 5, right? They stopped at 5 in this box when listing the first few counting numbers and whole numbers. We could have written more numbers if they were needed to make the patterns clear. So here's example 1.1. So it says, which of the following are A, counting numbers, B, whole numbers? So you have the numbers 0, 1/4, 1 divided by 4, a fraction, then the number 3, then a decimal with a decimal point, 5.2, that's 5 and 2/10, as we'll see later when we talk about place value and whatnot. Then 15, then 105. All right, so before I go to the answer, show the solution, let's go to some paper. So now you don't have to do this with a ruler, but when you're first starting off, picturing a number line, I think a ruler with markings on it is a very good model for a number line. Now you could do, I've got this one where you have the inch side, but just to get some more numbers showing up here, I'll do the side with the centimeters. So I'm going to draw this here, starting from the far left. Draw a nice straight line. Okay, and then we mark off. Now here, this point, that has a coordinate of 0. And then 1, 2, and I'm going every centimeter, marking off the coordinate for that whole number on the number line. Right, so 0, 1, 2, 3, 4. I'm just going to go for 10 here. I'm not going to go too far. Don't want to make this too long. 6, 7, 8, 9, 10. Again, and so on. All right, here is a number line where I have marked off the coordinates of just the whole numbers. And again, we can keep going with 11 and blah, 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 dot, 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 right, and so on. Now, the numbers they're mentioning, let's see if their coordinates match up with these here. So one of the numbers mentioned was 0, and that is exactly this first whole number I marked off. So that is a whole number. All right. So 0 is whole, but not a counting number. Right? Whole, but not counting. Right? Remember the counting numbers start at 1. All right, then the next number they gave us was 1 divided by 4, or 1/4, 1/4. Many ways to say that. That is not one of these. We're going to see later 1/4, 1/4 is a number between 0 and 1. So, when you're pointing out locations of, coordinates on the number line. So this is not whole, nor is it counting. All right, not counting, nor is it whole. It's neither. The next number they gave us was 3, which I do see here, 0, 1, 2. There's 3. All right, as a coordinate matching one of those whole numbers I put up earlier. So it's, it's a counting number. Remember, the counting numbers are 1, 2, 3, 4, 5, and so on. And if you're a counting number, then you are a whole number. Right? All the counting numbers are whole, but not all of the whole numbers are counting, as we saw with 0. Right? That's the only whole number that is not a counting number. Then we were given this decimal number, 5.2. Again, we'll see later that this is 5 and 2/10, 5 and 1/5. So this is actually, if you're pointing out a location on the number line, going to be between 5 and 6. So it doesn't have one of these coordinates. So just like 1/4, 5.2 is neither, counting, nor is it whole. All right, then we were given 15. Now, I don't have it here, but if I keep going, 11, 12, 13, 14, 15 is one of these counting numbers, or, whole numbers. Again, any counting number is a whole number. So this is one of the counting numbers, or I just keep upping it by 1 until I get to 15. And once again, if you're counting, you are also whole. All right, so it is both. And then they just make it even larger for the last part. The last number we're given is 105. Now notice it's not a fraction. All right, so like 15, like 0, like 3, it's not a fraction. Now I know we don't technically have fractions yet, but you probably have heard of a fraction before, like a number divided by another number like this. 1/4 is a fraction. Not a fraction. It doesn't have a decimal part, right? It's like the 5.2. It doesn't have a point something. Now, I guess technically you could say 0.000, throw a bunch of zeros on. We'll talk again about place value and decimals at a later time. But not a fraction, not a decimal. And if I were to continue bumping these up by 1, 16, 17, 18, 19, I'd eventually get to 100. So, and then eventually, way out here, we'd get to 100, then 101, 102, 103, 104, and 105 is indeed a whole number and a counting number, right? It is a counting number and therefore a whole number. All right, so the answers to example 1.1 here, 0 is counting a whole, but not counting, right? So when I'm going part A, part A was what are the counting numbers? Part B is, what are the whole numbers? So part B has 0, right? 0 is whole, but not in part A. It's not counting. A quarter is neither. 5.2 is neither. 3 was both. So you're going to have 3 on both of these lists. It's whole and counting. And same thing with 15. 15 is counting, and any counting number is also considered whole. And same with 105. All right, so here are the answers to example 1.1. So let's check it out. So see 0, not counting, so 3, 15, 105 for part A, and 0, 3, 15, 105 for part B, and then 1/4, 5.2 are neither counting nor whole. We will discuss these numbers later. All right. Then after this example 1.1, throughout this text, you're going to see these try it problems. I would highly recommend that while you watch me do these videos, pause the video and try to work out these problems on your own first before you watch me do them. Because if you're just watching me do them and you're not working yourself, you're more than likely not going to learn anything or not, pick up any of the material. You should be practicing not only these try it problems, but also exercises at the end of the section. Okay, so here's try it 1.1, same as example 1.1, where, which of the following are A, counting numbers, B, whole numbers. All right, so we have 0, 2/3, right? 2 divided by 3, a fraction. 2, 9, 11.8, another decimal with, this would be between 11 and 12, so not counting, not whole. Then 241, right? Not a fraction, no decimal point, so this is a counting number, a whole number. And 376, again, not a fraction, no decimal point. So this is also counting, and if it's counting, it's also whole. We already saw 0 in the example 1.1. Right? 0 is whole, but not counting. All right. So in my answers here, right, so this is try at 1.1. Again, part A, it's for the counting numbers. And looking through this list, you had the number 2, the number 9, the number 241, and 376. Again, these are not fractions. They don't have a decimal point with, some other number after a decimal point. So they're counting numbers, right? And therefore they're also whole, right? Part B was, what are the whole numbers? Well, all these are in this list as well. But then there was also 0. Remember, 0 is considered a whole number here. And then you had 2/3, right? You had 2/3 and 11.8 are neither. Okay, neither counting, nor whole. And if you want to check your results, because notice it's not like the example 1.1 where you could show the solution. If you'd like to see the answers for the try it problems, on the left, I know you can't see it, but I'll pull up the table of contents. And then at the very end, you should see answer key. And I'm in chapter 1. And there's these be prepared problems. And then you see the try it problems. And then here's 1.1. All right, this was try it 1.1. Part A, counting numbers 2, 9, 241, 376. Part B, the whole numbers, 0, 2, 9, 241, 376, exactly what I wrote on my paper. And the nice thing is, too, is that you see how the number 1.1 has a link. If I click on this, it'll take me right back to the reading in section 1.1. Look at that, right? I'm back to try it 1.1 from the book, from the section. All right. And then try it 1.2. Same type of problem. Which of the following are A, counting numbers, B, whole numbers? So again, 0 is a whole number, but not a counting number. It's the only one. Again, you have a fraction here, 5 divided by 3 with a numerator and denominator. Again, we'll talk about fractions at a later video, later section. Then you have the number just 7, and it's not a fraction, doesn't have a decimal point with some other number after it, to the right of it. So that's a counting number, and therefore also a whole number. 8.8, that is a decimal with a number other than 0 to the right of the decimal. So not whole, not counting. 13 is like 7, it's not a fraction, no decimal point with a number other than 0 to the right of the decimal point. So that's counting and also whole. And then 201, same thing, not a fraction, and it doesn't have a decimal point with a number other than 0 to the right of the decimal point. So this is also counting and therefore whole, right? Again, every counting number is whole. And I'll write this out and we'll check it. So again, this is try at 1.2. So again, part A was, what are the counting numbers? So 0 was not, 5/3 was not, 7 is, 8.8 is not, 13 is, and then 201 is. And then part B, right, the whole numbers. Again, 0 is whole. 5/3 was neither. 7, again, if you're counting, you're also considered whole. 8.8 was neither, and then 13 and 201, right? All the countings should be on the whole list. And I know they don't ask for this, but I'm going to write up, 5.3 and 8.8 would be considered neither of these things. All right, let's check it out. And back to the answer key, chapter 1. Try it 1.2, and you see 7, 13, 201 for part A, the counting numbers, 0, 7, 13, 201 for part B, the whole numbers. And then I click on 1.2. It takes me right back to the reading. Wonderful. Great. So hopefully that was simple enough. Identifying whole numbers and counting numbers and numbers that are neither. Being able to, locate coordinates of these numbers on a number line, right? A line with notches representing coordinates of numbers. And understanding that as you go from left to right, numbers increase As you go from right to left, numbers are considered smaller, numbers decrease. Right. And next time I'll be reading through the section heading with that's titled Model Whole Numbers. And thank you very much for watching.